Welcome to the Explainer. Today, we're pulling back the curtain on artificial intelligence to discover exactly how large language models, or LLMs, actually work. If you've ever felt completely overwhelmed by all the technical AI jargon out there, well, you are in the exact right place. We're going to break this whole thing down together, using simple visual concepts, one step at a time. So let's just dive right into it. You know that feeling when you ask a tool like ChatGPT a question, and it responds so smoothly that it genuinely feels like there's a real person typing away on the other end? It's super easy to assume the computer has a brain or that it's thinking exactly the way you and I do. But how does it actually generate those incredibly human-like responses? The reality is far more mathematical, and honestly, it's absolutely fascinating. Section 1, the AI magic trick. Let's just go ahead and shatter that illusion right out of the gate. Here is the fundamental secret. The model doesn't actually know anything in the way humans do. The Carnegie Mellon School of Computer Science puts it perfectly. The main goal during training is simply to maximize the likelihood of the next token given all previous tokens. Now, what does that mean in plain English? It means an LLM is essentially a giant, incredibly sophisticated autocomplete on steroids. It's been fed trillions of words from books and websites just so it can learn the statistical probability of which word should logically come next. It doesn't actually understand the meaning of life. It just knows that the word life statistically follows the phrase the meaning of. Section 2, tokens, the building blocks. To really get how it guesses those words, we first have to look at how it reads your input. When you type a sentence, the AI doesn't read the text the way we do. Instead, it chops your text up into smaller puzzle pieces, kind of like Lego bricks, and we call those tokens. Depending on the system, a token might be a whole word, a single letter, or just a chunk of a complex word to make it easier to digest.
Think about a simple sentence, like, I heard a dog bark. The system tokenizes that phrase, transforming it into a sequence of numerical IDs. The computer has no idea what a fluffy, barking dog is, but it definitely knows its token number 4. By translating our messy human language into a clean sequence of numbers, the machine can finally process it using math. And just like we have our own vocabulary, these models have a very strict set of pieces they can use. For example, the GPT-2 small model has exactly 50,257 unique tokens in its entire vocabulary. It's truly wild when you stop and think about it. Literally everything it ever reads and every single thing it ever writes is just a combination of those 50,257 puzzle pieces. Section 3, finding the hidden patterns. So what exactly does the AI do with these token IDs once it has them? Well, it looks for patterns. The model takes those tokens and drops them into what's called a token embedding map. Picture an impossibly massive library. In this library, words with similar meanings are shelved right next to each other. So the tokens for dog and cat are mathematically located very close together, while the token for calculator is way over in another wing of the building. This spatial map is what allows the model to capture the relationships between different words. To navigate this giant library, modern LLMs use a specific neural network architecture called the transformer. Introduced back in 2017 by researchers at Google, the transformer totally revolutionized AI. It allowed computers to process these tokens way more efficiently and actually grasp the context of an entire sentence all at once, rather than just reading word by agonizing word. Now, don't panic. This is the actual blueprint from that famous 2017 paper, but you absolutely do not need to memorize this math or understand every little box to get how it works. For our purposes, you only need to focus on one revolutionary concept that powers the whole thing, a mechanism called attention. The attention mechanism basically allows the model to look at all the surrounding puzzle pieces in your prompt at the exact same time to figure out the context. Let's say you type the word bank. Do you mean a river bank or a financial bank? By paying attention to the other tokens around it, like the word water or the word money, the model mathematically weighs the relationships between those words. It dynamically figures out the context, which helps it decide exactly which Lego brick needs to fit next. Section 4, predicting the next word. Now that it understands the patterns and the context, it's finally time to make a guess. So how does it actually pick the word? First, the model spits out what are called logits. These are just raw, messy scores for every single token it knows. Some are positive, some are negative. Since raw scores aren't super helpful, it runs them through a mathematical filter called the softmax function. And this is where the real magic happens. Softmax converts all those messy numbers into a neat, clean probability distribution that adds up to exactly 100%. Picture a game show roulette wheel. If your prompt is, "the sky is," the wheel spins, and the most likely next words get the biggest slices of the pie. The word blue might get a massive 80% slice. Dark gets a 15% slice. Falling gets a tiny 5% slice. The model then picks a word from this wheel. Usually it grabs the biggest slice, but depending on the settings, it might grab a smaller one to be a little more creative. Once the word is picked, it gets tacked onto your sentence, and the entire massive calculation starts all over again to guess the very next word, literally one token at a time.
Section 5, the illusion of understanding. Look, it's an absolutely spectacular technological trick, but we really need to stay grounded and remember what's happening behind the curtain. The most crucial takeaway here is that because these models are fundamentally just pattern matchers predicting the next statistical word, they do not possess true human understanding. They genuinely don't know what's true or false, and that's exactly why they can so confidently hallucinate completely made-up facts if the statistical pattern just happens to point them in that direction. They're incredible mimics of human language, but the understanding, that's just an illusion. Which brings us to the end of this explainer. And I want to leave you with a bit of a mind bender to chew on. If a purely mathematical model, doing literally nothing but predicting the highest probability next piece over and over again, can mimic our conversations so flawlessly, does that mean the machine is starting to think like us? Or does it suggest that maybe we humans are just highly advanced autocomplete machines ourselves? Thanks for joining me, and keep asking those great questions.